Hi everyone, my name's Tobi Bosede. I work at a large bank. I do a lot of Java development, previously did Python development, work in the credit portfolio group, so a lot of finance and technology. Today I'll be sharing with you about PyCassa and how to set it up along with Cassandra. So basically Cassandra in Python. So what's Cassandra? Cassandra is an open source NoSQL database. That basically means it's non-relational and it's distributed to handle large amounts of data across multiple servers. So the precursors to this were Bigtable, which is from Google, and also Dynamo. So it merges those two technologies. What problems does it solve? In terms of storing massive amounts of data, that's a very large strength with Cassandra. It's scalable. It's also schemaless, so if your data is unstructured, you can also utilize Cassandra. It's fault tolerant, so I talked about the distribution. If one node goes down, all your other nodes are still working and you don't lose any data, nothing goes wrong. There is no master. It's masterless, so all the nodes can do the same work as another node. No one node is central, so once again, that's why if one node goes down, you're okay. There's also fast retrieval. It's based on a key value data store model, so that means that your data is indexed. How do you install Cassandra? So Cassandra has a website. There it is. There's a tar file. You just download it and a zip. That's a little typo there. You have to set up a home environment variable, and make sure you have Java 7 specifically. Then there's a YAML file that you have to edit. That's your config file. You just have to add your directories in there, and there's this link here that kind of details it more. In terms of actually starting Cassandra, you have to go to where Cassandra is located, type in this command right there, and then you'll see a message listening to Thrift clients. So I'll just demonstrate for you guys really quickly here. Okay. So depending on your processing power, this can take like a second or a couple minutes, as it is in my case. So it's doing all this background work, and then eventually we'll get this message right here, listening for Thrift clients. So what is Thrift? What does this mean? Let's look at that. It's an interface definition language, and what that is something that describes the software components interfaces in a language-independent way so that there's communication between different languages. It's kind of like, I guess, a way to translate. There's also, in this case, between Python and Cassandra, easy access. So specifically, the focus here is PyCassa, which is a Python wrapper, and it's built on top of Thrift. How do we install PyCassa? There's a GitHub repo for it, and you can manually install PyCassa that way, and I actually prefer using Git because you're supposed to also be able to use pip, but when I pip installed PyCassa, I was missing the PyCassa shell. So that's what it says here in this sort of last sub-bullet. And a prerequisite, as I discussed before, is having Thrift. So you can pip install that, or it comes with continuums and a conjure distribution. So connecting to Cassandra using PyCassa. First, you just want to check that you properly installed PyCassa. And one way to do that to a degree is by importing PyCassa. And if you don't get any errors, then it probably correctly downloaded. So now let's actually start the PyCassa shell. You go to the directory where it's located, and then you just type in this short command, python PyCassa. So let's do that. So once again, this is dependent on processing power. It'll take a few minutes. Okay, there we go. So Cassandra, interactive Python shell. What does that mean? It's basically IPython. And if you are familiar with IPython, you'll notice that it already kind of looks like IPython with the in1. Moving on. So there's this whole idea of key spaces and column families in Cassandra. So in PyCassa, we want to type up these commands that I have a screenshot of. So we're creating our key space in the first line. Then we're creating our column family. And so these are things that we only need to do once. Here I have dummy key spaces. I call them key space 1, column family 1, dummy column family. And then we have to actually, here is where we're really connecting with Python. So this is, every time you open up PyCassa, you would have to do this, but just once. So what is a key space? It's similar to a schema in a relational database. So they basically just group columns together, and column families, excuse me. And what is a column family? It's similar to a table from a relational database. So I talked about schemas, I think. I said that Cassandra is schemaless. So what is a schema exactly? In a non-relational database, typically you must, not typically, you must predefine your columns and your data types. In Cassandra, that's optional. And you probably actually would want to just add that schema anyway. If your data does have structure, it's easier to just have that, availability or ability to add a schema. And so even though we have this idea of a schema in Cassandra, the storage engine is different, so that it's still very, very unlike a relational database. For instance, here we're looking at an example of a schema in Cassandra. We can notice that there's this whole area where there's no data. It doesn't even say, it doesn't say null, it's just empty. So that's a big difference, because these nulls do take up space in a relational database, whereas here we're okay with not filling that area up. And that adds to Cassandra's efficiency. So there's a sparse column engine. Space is only used by the columns present. So this whole birth date column isn't present in the third and fourth row. We're not gonna fill that up with anything. So I was mentioning that it's recommended to create a schema if you do have structured data. There's a blog on data stacks that kind of details more about Cassandra's schema structure if you want to find out more. But here, we're just adding data. That's what the screenshot is. So I talked about the key space, which is like the schema, and the column family. So once that's created, here I'm inserting dummy data, this first row with And here you can also see the column, the key value structure coming in. But so this is just inserting a row of data right here. That's what this shows. And what we get out is actually a binary object. However, we can actually retrieve that. So right here is a command. There's a method .get, which allows us to retrieve that data that we just put in. There are similar numbers of commands in PyCassa, like get count, different methods, similar to what you would see in a relational database. So there's a lot of crossover. There are more ways in this link I've provided there. So I said I would get more into nodes and what they are. They're servers that help distribute and replicate the data. And together they form a cluster with varying topologies. What we have to do if these are physical is we have to assign each server or each node a unique token so that we can figure out what data is being stored there. So if we go back to the schema that I pointed out before, basically this first column right here would be the primary key. And then within that, you would have basically like replication keys. So there's just a way to divide all your data and assign that to a specific node. And so a row name in the column, I'm losing my cursor, so like maybe we would pick this as our replication key, and that would help the node figure out like which data is going where, what it's replicating. Whoops, sorry. Okay, so the next thing is, so here there's just a link, I forgot to mention this. There's just a link with how you can set up a cluster in Cassandra to learn more. Okay, so, this isn't actually necessary to do until you actually, need to add more memory to your cluster. You have more data you need to add, and you've completely exhausted your current server, your first machine, which is your seed. However, so I talked about this whole idea of having tokens and needing to assign each node a token, but if you use virtual nodes, you don't actually have to do that, so it's easier to manage. There's this whole idea of rebalancing, and that's gone when you're using virtual nodes. So I guess I think I have a little bit more time. Any questions? Well, actually, yeah, this was motivated by something I was doing at work where we were having trouble with queries taking too long and just having too much data, because this is, when you have like terabytes, petabytes of data, something like this that scales well and you don't have to change the schema is a lot more convenient. So I was playing around with this, at work. Any other questions?
So when you dump data to database, we're able to specify the precision of data, like I want to have a precision, single precision, where is it?
Position, you're saying?
Precision.
Okay. Oh, right. Yeah, definitely. Yeah, you can do that. That's the whole idea of the schema. So you can predefine the data types, yeah.
Okay. And say when you so I think it's for pandas, for example, in the Python, if I use a pandas to have the data frame, I want to dump this data. I guess for the index, it can have like the duplicate indexes, right? So, for example, they have the
In pandas, you're saying?
Yes. When you dump into the database, does the primary key has to be unique, or it also supports like duplicate?
There are duplicate columns, yeah. The whole fact that it doesn't actually store it doesn't store like it doesn't store like it doesn't store all columns. So for instance, like here, like rows 3 and 4, I was saying that we don't need to put anything there, not even a null. So with this comes the fact that we're replicating the column names.
But what if the index actually have duplicate? Does the index has to be unique, or you can have duplicate?
Oh, that's what you're saying. Okay, no, those would be unique.
Has to be unique.
I believe so. Any other questions? Go ahead.
Is there anything that's available in general Cassandra that's not available in PyCassa that you missed?
Oh, right. So I didn't really talk about the whole CQL, but an alternative to Thrift, which is basically what PyCassa is, it's using Thrift to communicate with Cassandra. You can use what is called Cassandra querying language, and it's basically like SQL. So the things I talked about, the different commands, like here we're inserting or we're counting, you know, like that, there's an analogous version of that called CQL, and it's very similar to SQL. So I think if you're coming from a relational background, it might be easier for you to kind of like adapt to Cassandra if you were using CQL. So that is an alternative to PyCassa. That's a good point.
So I sort of a general question. How fast is this able to crunch data? You said you're dealing with like terabytes.
Mm-hmm.
If you were going to take like the average of however many data points, how long approximately would that take?
To query?
To query and to run the whole system.
Well, what do you mean by run the whole system?
So I'm just curious. So say I had like I was on a database with like 10 gigabytes.
Mm-hmm.
I wanted to take an average of 1 point in for every single one of those data points.
Oh, you mean like doing data analysis, more like
how long
that?
would it take to just, I'm just curious to get an idea of the sort of order of magnitude.
Well, it definitely would be a lot faster. Like, and you're talking about just, what did you say, 1 gigabyte or something? I don't know what you said. But, you know, with something like that, it's definitely not, you know, milliseconds or something, even faster. I haven't actually timed any of these things, but, you know, really the strength of Cassandra is when you do have those really large sets of data. And even with that, I mean, you know, with more data, you would have more servers, more nodes in your cluster. And you do lose a little bit of speed with, in terms of querying and returning data. But it's not the same as, for instance, with a relational database, where there really would be a bottleneck. Yeah.
In what context do you use Cassandra in your workplace? Is it as like a static store?
Well, so I actually was just exploring this. We didn't actually implement this at my job. But I know Facebook uses it. I think Amazon uses it. Some other major companies that really rely on this. But I mean, I would say, you know, if you're dealing with massive amounts of data, that would be a good use case for exploring Cassandra. You had a question?
You demonstrated the installation on a Windows PC, right?
Right.
You can still do it on a Mac using pip and other stuff.
Yeah, you could use pip on Mac. But in terms of installing, like actually that was actually, I showed you connecting to it, or starting I showed starting Cassandra in Windows, but installing it is really the same process on any operating system. You're unzipping the files, it doesn't matter what operating system you're on, you can unzip files, setting up home environments. This link is Windows specific, so how you would get to where your home environments are might be different on a Mac, but the same ability is possible. Editing config files, that's just me opening an editor and I'm typing stuff in. So, every operating system has editors. So yeah, this part wouldn't, I don't foresee that being an issue. And I believe the command isn't different either for starting Cassandra. The spin Cassandra, I believe it does apply for OS, for Macs.
How's Cassandra different to other NoSQL databases?
Oh, like MongoDB? That's a good question. And I once saw, So I once saw kind of like a graph comparing Cassandra to things like Mongo. And basically, when I was talking about sort of like the reasons you would want to use Cassandra, scalability, fast retrieval, some of the other NoSQL databases, they're not as easily scalable, for instance, because they're different. I also talked about the key value store model. There are different models underneath various NoSQL databases. So that affects something like the ability to retrieve data, or usually though, I believe that they do all have, all the NoSQL databases do all function with a node cluster type idea. It's just that, how do you actually like implement that idea? Here in Cassandra, it's masterless. So I'm not, exactly sure about Mongo, but that's one area. Maybe other NoSQL databases do have a master in their cluster. Anything else? Okay, well, ended a little early, but thank you.